Alrighty, so here's what we're up to. We're graphing simple non-linear equations. Now, this is just the first part though, so we can see there'll be a couple of parts to doing this full graphing, but our focus is going to be is looking at the y-intercept. So that's our focus for this quick video. So what I wanted to do, first of all, was just to ask you, what is the y-intercept of the graph in the picture below? Now, all the y-intercept is the point at which the graph cuts the y-axis. So if I go like this, we've got our graph there. So all the y-intercept is the point where the graph, this is the y-axis, this is the x-axis. It's the point at which the graph cuts the y-axis, and that's here. So here we're asked, what is the y-intercept of the graph pictured below? And the answer is just y-intercept equals 2. Because that's that number there. So that's easy. Now what's the next thing we need to look at? Another question. If a graph has the equation y equals 2x plus 3, circle the point on the axis below that represents its y-intercept. Again, we'll paste this one here. Drag it down a bit so we can see the question this time. I'll leave it like that. Okay, so circle the point. Okay, so here's another key thing. So we've got a couple of components to an equation like this. The general form we give it, the number that goes in front of the x is always going to be the gradient. And the number that we're adding on is always going to be the y-intercept. So when this says graph has this equation, circle the point on the axis below that represents its y-intercept. Well, it's going to be where this graph cuts the y-axis, isn't it? So it's going to be somewhere along this axis. The y-intercept is always on the y-axis. And then here we can see it's just 3. So 2, 4, halfway between is 3. And it said circle the point. Okay, so easy enough so far. What about the next question? I've got a question here. Sam the sloth, sets out from his tree at around midday and walks north. This graph represents Sam's journey. Based on an observation of the graph, at midday, how far north of Sam's tree was Sam? So this is the distance north of Sam's house, and this is the time, and in minutes past midday. So let's pull this one over to our where we were before. Let's put this one down the bottom for now. Okay, so what's this? This is distance north of Sam's house. So at this point, he's 6 kilometers north. At this point, he's 8 kilometers north. And he starts off, this is time, minutes past midday. So if this is 2 minutes past midday, he sets off at 2 minutes before midday. But the question is, how far north of Sam's tree was Sam at midday? So this represents 0 mins past midday, which just equals midday. So what this question is really asking for is what is the y-intercept of this graph? And the y-intercept is 4, right? But this 4 isn't just a number, it also has units, and it's 4 kilometers north. So we could write a sentence, at midday, Sam is 4 kilometers north of his tree. So that's kind of getting you used to interpreting what the y-intercept is all about. Here we can read off as this, hopefully that was clear enough. Alright, next question. Sam's wife, Simone, they're both sloths, and her journey is represented by the blue line because we just saw Sam here, also sets out before midday, but a little bit earlier than Sam. So she sets out here. So she's actually setting out, leaving the tree 5 minutes before midday, whereas Sam left it 2 minutes before midday. How far north of their tree was Simone at midday? So she was going a bit slower, and you can see they caught up to each other here. But here, basically the question's asking, what's the y-intercept? And we can see 5. Therefore, at midday, Simone was 5 meters north of the tree. Alrighty. So this is just kind of a recap of what we've looked at. This y-intercept concept is really not that hard. It's basically just where does a line cross the y-axis. So this is a bit of a summary slide. Here it crosses here. So it passes through the y-axis. Oh, that's tasty. That's to do with another question. Forget about the tasty. At about y equals -1. We could call this point 0, -1. So when we have a list coordinates, we're always going the x coordinate, which is 0. We're 0 along this axis because we're in line with the 0. And then we're at -1 on the y-axis. And then note our coordinates are labeled x, y. So the letters are in the same order as those two letters appear in the alphabet. Thus, we could say that the y-intercept for this line is -1. We call this point the y-intercept, and it's the c in the general form of the linear equation y equals mx plus c. So you'll probably see this a lot when you're dealing with linear equations. Our m represents the gradient and the c is the y-intercept. And a way to think about that is it's where the line c cuts the y-axis. And the final thing I wanted to show you was this slider. So this is a graph y equals mx plus c. And what we can actually do is we can vary this y-intercept. So we can see now in this equation at the moment, the y-intercept is set to 0, which means that the graph is cutting the y-axis at 0. But we can change this with this slider. Here they've called it b, but we've called it c in our equation. And this b can have its value varied by this. So say I take this b value and I slide it all the way up to 10. What do you think this graph's going to look like? Let's have a look. Slide it all the way up to 10. What I've just done is I've made the y-intercept is now 10, and this line now cuts the y-axis at y equals 10. What about if I slide it down to 5? How's it going to look there? 5.15. What a surprise. The graph, the linear graph, is cutting the y-axis at y equals 5. So the y-intercept is now 5. One final example. Down to 1. The y-intercept is now, we're at 1.1. That's okay. 1. So y equals mx plus c. C is a y-intercept. Y-intercept is 1. Cuts it at 1. So hopefully that's a clear enough explanation of our starting point of any linear graph, which is the y-intercept.